Good afternoon. Welcome to the last day. You made it this far and you're still attending sessions. That means you must still have some energy left to learn, which is great. I hope something useful will come out of this session for you. And I know we all just ate lunch, so you might be a little sleepy after this, so I'll try and keep it really interesting. Today we're going to talk about how to build a how to not build a distributed monolith, or in other words, how to avoid doing microservices completely wrong. I want to start out by telling you a little bit of a story. I'm a consultant. I am one of the owners of a consulting company called Trailhead, and we help our clients build custom software applications. And very frequently we'll have clients come to us like we did recently that have built what they call a microservices application. And oftentimes they'll come to us kind of right at the end of the project, just before it's supposed to launch, and they'll say something like this client told us, which is, we have a little bit of a performance issue with just a couple of the endpoints that we'd like you to get your help to fix before we go live. So with this client that came to us recently, that was also the case. And we started looking at their code and started looking at the architecture of the system that they had built. And it didn't take us very long to realize that what they had built was not at all microservices. What they had built was actually a distributed monolith. Now, if you're not familiar with this term already, I hope you are by the end of the talk today. This is the bad guy. This is the villain in our story today, the distributed monolith. That's why I put it in this scary font. Are you all scared? This is far from the only time this has happened. This has happened so many times with clients coming and saying, we built this microservice, it's not working well. And then we look at it and say, oh, this isn't microservices at all, this is a mess. And it happened so many times that I started thinking, I need to start collecting and sharing this information with the world. So that's what I'm doing here. This is the talk that I created based on that inspiration. I'm going to talk about a bunch of things today, but the main thing we're going to talk about is I'm going to share with you the 10 most common mistakes that I see our clients making when they try to build microservices and end up building something much worse called a distributed monolith. Hopefully this will help you avoid making these same mistakes. A little bit about me before I get started. My name is Jonathan Tower. I go by Jay for short. As I mentioned, I'm a founding partner and principal consultant at Trailhead. We do custom application development consulting. You can contact me at all these places online if you're interested in getting connected afterwards. I've also got this GitHub link here, which will take you to these slides if you're interested in looking at these again later. I'll also post these on the Slack channel if you're on that. I'm also a Microsoft MVP 9 years in a row for .NET. Started out in ASP.NET, and then that got merged, and now I'm on .NET. And one other thing I just wanted to mention on this slide, I'll show this slide again at the end if you want to get any of this information again. But something special I like to offer to anyone that comes to one of my talks is a free consultation. I know we'll have some time for Q&A hopefully afterwards here. If you want to come up and talk to me afterwards, you're welcome to do that too. Sometimes maybe we're a little too embarrassed about the problems that we're having with our software, and don't feel free to do that in public, or maybe there's something proprietary or some context that you need to give me first. If you want to do a free 30-minute session with me and we can talk through what you're facing, I'd be happy to do that. You can go to this bit.ly link or this QR code and sign up for free. All right, so before we get started with the 10 most common mistakes that I see, let's make sure we're talking about the same thing with some definitions. So let's start with the definition of a monolith. Monolith is a traditional architecture of software development. If you've been doing this for very long, you've probably built many monolith applications before. It's easy to get confused nowadays. There's so many talks, even at conferences as good as NDC. There'll be a lot of talks about microservices, and it's this buzzword, and you start to get the impression that everything should be a microservice and nothing should be a monolith. And hopefully the one thing I really want to convince you of today in this talk is that that is not the case, that monoliths can be good too. In fact, we've been building scalable monoliths for decades now, before microservices was ever an option. They're actually much easier to build than microservices are, They're actually also better at something called data latency, which is basically how long it takes from when you enter the data to when it's available, stored and available for the whole application to use. So there's a lot of pluses to a monolith. There are disadvantages as well. One of them is that if you want to make a change to a monolith, even if you're changing something small like the name of a button or the word that shows on a button, that requires you to change the whole application, right? We've all had this before where maybe there's a misspelling in one of our applications and you need to update it. Well, you have to rebuild the entire application and it has to go through your release pipeline and you have to update the entire application just to change that one button. So that's kind of a downside to the monolith. That does also mean that there's more tight coupling between the components of a monolith, which means it's possible to write some code that brings down the entire thing, right? If you have a class that's used in every single part of your application, you can imagine like a logger or something like that. You can imagine that if you put some bad code in there, that would bring down your entire application. And then finally, one of the disadvantages is that you have to use the same technology stack. When you're doing a monolith, you have to build the entire thing using the same stack of technology because the whole thing is built and deployed together. You also, this really works best if you have a small team that is all working on the same thing. And it doesn't work as well if you're trying to have a huge team with lots of different people focused in just specific areas, working in just their specific areas of expertise. What's a typical monolith is going to look something like this. It's going to have clients that are connecting to a middle tier part of the application, and then some sort of a data store like a relational database or a NoSQL database. This is your typical application architecture. One of the common reasons that I get that people say that they're using the microservices architecture is because they want their application to be scalable. Now, that is true that microservices are more scalable in some ways than monoliths, but monoliths are scalable too, and you probably all know this. I'm probably repeating information that you know already, but you can scale up a monolithic application by adding more processor cores, more memory. You can also scale up the database portion the same way, right? You can make a more beefy server or virtual server to run your application, and you can scale it up that way. You can also scale horizontally when you're doing a monolith. This is most commonly done with things like load balancing on the middle tier, or if you're talking about on the back end storage, you're going to use something like data sharding, where you're splitting your data up and storing it into different data stores depending based on one key or other, like your user ID or your customer ID or something like that, that is a good key to kind of split your data up based off of. So there's lots of ways to scale a monolithic application. And I want to underscore that just because I hear that reason so much, and it ends up oftentimes, as I talk more to those people, I'll find out that it's the only reason that they built microservices, and it turns out it's actually not a good fit for their needs. There's actually a couple different kinds of monoliths. Hopefully you've been hearing me say this already, that monoliths aren't always bad. So there is something that I call a modular monolith. This is hopefully the type of application you've had the chance to work on before, where you can go into the code, you can change things really easily. You don't have to change things in 5 places to make one simple change. Changing something in one place doesn't break something in another place, right? It's basically a well-designed, modularly created, low coupling monolith. It's still a monolith if you have to compile the whole thing together and the whole thing goes through one DevOps pipeline to be released. It's still a monolith if you have to release the entire application just to update one part of it. But it could be a really well-designed monolith, and therefore it would be a modular monolith. Now there's another kind of monolith, which is I think the one that we all think of when we hear that word monolith, which I call the ball of mud monolith. You know you've worked on one of these before if you go into the code to try and make a change over here, and then you find out from QA or from your users that you broke 5 things over here. If you know that you're working on a ball of mud monolith, if every time you make a change, you break things that you don't realize you're breaking, and your customers, your end users are mad at you all the time because there's always seems like you're making the system worse instead of better, it's probably because it's a poorly designed monolith. Now that doesn't mean that microservices is a bad fit for you. If you're on a ball of mud monolith, you might be a better fit for that project to go to a modular monolith architecture, and it might be a better fit to go to microservices. By the end of this talk, I hope you will have an easier time identifying those situations. Next definition I want to cover is microservices themselves. Now, I think there's a very interesting definition of this that Google uses internally for their teams. They refer to the definition of microservices as both the architecture and organizational approach to software development. Notice that. It's both an architecture and an organizational approach. Why do I want to underscore that? Because I bet all of us, before I said that, think of microservices primarily as an architectural approach, right? But it's very important, I think, to realize that not only is it an architectural approach, but it also requires you to reorganize your team, your processes, to actually fit microservices. The rest of the definition Google uses internally is it's a kind of software approach and team organization that leads to software composed of small, loosely coupled services that communicate with each other through well-defined messages and are owned by small, self-contained teams. So that's back to that organizational structure that I mentioned, right? Small, self-contained teams. There's a lot of benefits to microservices. If you have a well-designed microservice and part of your application gets a lot more traffic than another part of your application, you can scale up just that one part of your application. So that's more like targeted scalability or precision scalability. It's also possible to take part of your application down for maintenance while another part stays up and completely operational. Imagine you have part of your application that's taking orders. Maybe you do millions of orders an hour and you don't want to lose money by taking that down for maintenance, but you have other parts of the application that need to be updated more frequently. Maybe like user profiles needs to be updated occasionally. Well, you don't want to take down your ability to take orders in the middle of the day just so you can update the user profile part of your application. So microservices are really great at that. Of course, I mentioned before different technology stacks. That's possible in microservices. I don't see a lot of teams doing this, but you could imagine that maybe part of your team is more familiar with Java. That's okay, you can be friends with them anyway, right? Maybe part of your team's more into .NET. Those are obviously the cool people on your team. Maybe someone is into something cool like Rust or Go. But you could have different parts of your organization that has different expertises, and they could build their part of the application in whatever technology stack is the best fit for their part of the business. And then also I mentioned the team organization. So if you're doing microservices, it makes a lot of sense to have separate teams who are each focused on different microservices, and they become experts in that part of the business. And really, there's very little need for them to cross over into other parts of the business. So then the villain of our story, the distributed monolith. What is a distributed monolith? Well, nobody sets out, hopefully, to build a distributed monolith, but when you get a distributed monolith, usually it's because you set out to build microservices, but you created them in a way that were tightly coupled. And when you deployed a tightly coupled application in a distributed way, it became much worse than if it was just a monolith, or obviously if it was a pure microservices. This is what a typical distributed monolith is going to look like. I'm sorry, this is what a typical microservice architecture is going to look like. A typical distributed monolith architecture is going to look just the same, except because you're setting out to build microservices, but it's going to fail in the sense that all of the services are going to be talking to each other. Maybe they're going to be accessing each other's databases. Maybe they're going to be sending synchronous HTTP REST calls to each other. All of these types of things create coupling between these applications, and we're going to talk about a lot of examples of this as we're going into detail. Now, I specifically left the event bus off of this slide, but I want to show you that most people who set out to do microservices will include an event bus because they will have read on a blog or something that you're supposed to have some sort of an event bus or a queue. And so they will include it, but then because they're sort of used to building a monolith, they know how to have one module call another module, and so they'll write their code the way that you would write a monolith, and they'll just have one service calling another. Maybe the most popular way I've ever seen a microservice built is this one. I love to show this slide because once I get to this point, most people are tracking with me, and I get so many smiles when I put this slide up because I think people come up to me afterwards and say, this is what my company is building right now. It's microservices, but the DBA, when we told him we were building microservices, he said, over my dead body, right? And I can give DBAs a little bit of credit for that because they've been trained their entire careers and their entire education not to repeat data, right? Normalize data, don't have multiple copies of data, don't try and synchronize data all the time. Try and get it all into one place, put it into nice normalized tables with perfect relationships between each other, and they're trying to protect that, right? So you come to them and say, hey, we're gonna do microservices, and they say, well, in that middle tier, you can do whatever kind of crazy architecture you want, but you're not touching my database, right? So this is what I see frequently at companies, and they end up saying, look, what we'll do is you can just put everything in the database, and I'll set it up the way that I normally would, and all these different applications can call it, and that'll be microservices. Well, we're gonna look at today how this creates a lot of coupling between these applications that makes them a distributed monolith. So if you organize these a little bit on a graph, the ball of mud monolith is monolithic physically. It's deployed as a single piece, but it's also logically monolithic. Everything is tied together so tight, you can't really separate things, you can't update things easily. The modular monolith, which is a perfectly great architecture, it's more modular in the way that it's logically organized, but it's deployed as a single piece, so it's still physically monolithic. The distributed monolith is what you get when you try to create microservices, but you end up creating them in a logically monolithic way with all the code referencing all the other services. And so you end up with it being physically distributed, but still logically it's monolithic. And then you end up with true microservices up there in the corner where you've got it both physically distributed and logically modular. So now that we're all on the same page, hopefully, about those terms, let's jump into these 10 most common mistakes that I've seen companies make over and over again. The first one, maybe this one won't surprise you at this point in this talk, but number one is assuming that microservices are always best. There's some great books out there about microservices. Maybe you've read some of them. Sam Newman from the UK has created one that's really excellent. He says in that book that if you're going to do microservices, you should have a really good reason, is what he says. Now he goes into more detail to describe some of the reasons that he thinks are valuable reasons, but I've kind of outlined a few of the downsides here. If you're trying to do microservices just because you're looking for something that is scalable, well, monoliths can be scalable. We talked about that already. Microservices are really hard to do. Based on my unscientific survey of our clients who've come to us looking for help, I would say over 90% of microservice projects are actually some kind of a distributed monolith. Nowadays, it's such a buzzword, but nobody's really been doing microservices for 10 years or anything like that. So probably there's nobody on your team who says, oh, I've built dozens of successful microservices. I know exactly what to do. So you're trying to figure it out. And when you try and figure it out, you very likely, if you haven't been to my talk, will make some of these 10 mistakes, and it's very easy to end up in the wrong place. And then finally, the wrong reasons to create a distributed monolith. So what are some good reasons? I talked a little bit about independent scalability, so scaling different parts of the application. Talked a little bit about independent deployability, if you have to be able to take parts of the application down frequently while you're leaving other parts up. I attended a DevOps talk a while back with an Amazon engineer. He was talking about, at the time, for Amazon.com, the e-commerce site, they were doing tens of thousands of updates to the website every day. Tens of thousands of releases happening in a day. Now, if you had a monolith, basically your application would be down all day, right? Like a lot of my builds take 4 or 5 minutes, and then it takes another minute or two to do the release. You couldn't even do 10,000 in a day if it takes that long. Your application would be down all day long, right? they need to, at Amazon, they need to be able to do independent deployability. They need to be able to update parts of the application without taking any of the rest of it down, because they would lose millions in 50 seconds if they were down, right? Isolating the surface area of failure. If you have part of your application that takes orders, or it's where the money comes from for your business, you probably want to make sure that that is as isolated as possible from all the other systems. You might want to have queues, event-driven development going on behind the scenes so that it can take orders even if all the other systems are down for a whole day and just queue them up. So that's something that you can do much easier with microservices. And then I mentioned it a couple of times, but independent teams. If you have 60 developers or 100 developers and they're all working on a very large application, but they're all kind of focused in different areas of that application, well, then it makes a lot of sense for that team to work on a microservice. There's a big trade-off with microservices, which if you only remember one thing from this talk, I want it to be the last thing, which is that microservices aren't always the right thing for every project. If you only remember two, have it be this one. Microservices are inherently bad at immediate consistency. They have something called eventual consistency. They're very good, if they're designed well, at something called high availability. So microservices, someone can trip over the power cord in the server room and bring down one of the microservices, and all of the other ones are still fine. Someone can write some bad code and deploy it to one of the microservices. All of the other microservices will still run. But because of that distributed nature of a microservices architecture, all of the different applications are going to get data updated to them eventually. That's that eventual consistency. Monoliths usually will have a single data store, or at least a single data store per like data shard. And because of that, they'll have immediate consistency. As soon as you finish the database transaction of writing, then everything in the application is aware of that new data that's been written to the database. They can now read those updates, right? So if you want high availability, microservices might be the right architecture for you. If you want immediate consistency, then monoliths might be the right architecture for you. I mentioned this when I was showing you what the typical architecture looks like for a distributed monolith, but very commonly I see the data store, the database being shared between the different microservices. Another one that you might have not thought of, though, is the data models themselves, the models that represent that those data stores. So imagine you have this scenario where you're building what you intend to be microservices. You have all these different services, but they're sharing a database. And service one over here has a team that says, we need to make a breaking change to this table in the database, but it's our table. It belongs to our microservice. So we should be able to make breaking changes to it because we can update the code and we can deploy those changes all together. So they go ahead and break something in the schema of this database. Now, even if you set out to not share databases, as soon as share tables, even as soon as you have the same database, I guarantee it'll happen. I've seen so many projects start out where they said, well, we'll each have our own schema in the database, and we'll have different logins with different security. And what ends up happening is somebody gets lazy and says, I really need that table, and I don't want to wait for an event to publish the information from one service to another. I'm like already connected to this database. I'm just going to do a real quick select statement and get that information right from the database. It'll definitely happen if you allow everybody to connect to the same database. So what happens when team 1 breaks the schema? Well, team 5 over here didn't know about it, and maybe team 1 didn't know that team 5 was cheating and looking at the schema of a table that belonged to team 1. So now microservice 5 just broke. So is this high availability? Is this independent applications? No, right? It's very easy when you're sharing a database to accidentally break things. So what do we want it to look like? We want it to look like this. Every application has its own database. If they need to share information, they should do that through asynchronous method like an event bus. This is the quote unquote right way to do microservices that will not create coupling between these different microservices. Let's look at an example of data models as well. So imagine you're writing all of your code in C# for all of these microservices, and you're used to doing monoliths, so a lot of your applications, you'll have these like massive Visual Studio solutions with 20, 50 projects in them, right? And you're used to doing things that way, so when you start creating microservices, you do the same. You create a class library, and it has all of your data models in it. And everyone can access that. That's kind of how you would normally do it in a monolith. Well, in microservices, that should probably be actually separate libraries, one for each. And I know that also, sort of like the DBA I was talking about earlier, that sounds like it's breaking all the rules that you've learned over the years about how to design good architecture, right? Everyone's learned dry, don't repeat yourself in good coding. And if you're doing microservices correctly, you probably do need to repeat yourself. So imagine this scenario. I just stayed in a hotel since I'm visiting from the US. Imagine that the hotel I stayed in has microservices for all their different parts of their business. They want to be able to take reservations all the time because they want to, they don't want that part to go down. So maybe it's a good fit for microservices for them to use this. And they've got maintenance and housekeeping and maybe some other microservices in there. They've got, obviously, a hotel room object is going to be a really important one in their data model. So right now, all of those services are sharing that same model for their hotel room data. It's got information in it like, is it occupied currently? It's got how many beds are in there. It's got how long it takes to clean. Maybe it has like a related entity that's like a child entity that's like the repair history in that room or maintenance requests or something like that. So now what happens if the housekeeping service says, you know, we don't really care how many seconds it takes to clean a room, we care how many minutes. So we're going to go ahead and update that from a float to an int. Be a little bit less accurate, but it's plenty enough accuracy for us to know how long to plan for every room to be cleaned. So they make that change. Well, if everyone's sharing the same data model, before they do an update to their system, everyone else is going to have to do an update to their system because now they have the wrong type that's not going to match. The model is not going to match their data stores because maybe all these other microservices are still using a float for that minutes to clean property. So because of this, what you actually want to do is you want to split these data models up. Ideally, you would put the data in only the place that it's needed and then copy it to all the other places through events if other places need that information as well. So in this example, I have the hotel room under reservations, whether it's occupied, and the number of beds. I have a different hotel room under maintenance that just has the repair history, and I have a different hotel room under housekeeping with just the minutes to clean. So you might already be asking, like, well, what about those examples, Jay, where there's data that all of these applications need? So here's an example. Let's say you have an admin service that's like your back-end administrative interface where people can do things like creating new hotel rooms. Maybe there's been an expansion to the hotel and there's now some new rooms that you want to add to your hotel. So you go into your admin module and you hit the service that adds a new hotel room. It stores it in the admin module. The admin module then will create an event. Let's say it's like a hotel room created event that it will publish onto the queue or bus. And then anybody that has subscribed to that event will get that event. And depending on what technology you use down here for your event bus, you can make it so that even if these other services are down for maintenance, that they will get this, when they come back online, they will get these events. You can make guaranteed delivery. So all of these subscribers will get this information, and they can now update their own copies of this data to say, I now know about hotel room 124. The last I knew, the hotel rooms only went up to 123, and now I know about hotel room 124. I'll go ahead and create a record for those in my part of the system as well. So that's kind of how you would do it with the event bus and without sharing your data models. Mistake number 3 is microservices that are too big. Hopefully many of you are already familiar with DDD, or domain-driven design and development. If you are not, this is a great book that you can use to get started learning about it. It's a large and fairly complicated topic, so we don't really have time to talk about it in a lot of detail today. But I do want to mention that if you're trying to figure out where do I draw the lines between different microservices and what goes in this one, what goes in that one, what you really want to use is this concept of bounded contexts, which comes from domain-driven design. It's pretty tricky, and it takes some time to get used to. So I recommend starting with this. There's also some other great books about it that I'm sure you'll be recommended on Amazon as soon as you add this to your cart. I have a simple rule, since we don't have time to get into 2 hours of domain-driven design and development stuff right now. My simple rule is that you're trying to create the smallest possible microservice without creating chatty communication between your services. Now, I'll give you an example of this after my next problem, which maybe predictably is microservices that are too small. So let's imagine an example where you have been to a conference, they talked about microservices, you said, I'm going to microservice everything. From now on, I'm microservicing all the things. And what's more micro than a single endpoint per service, right? I'm not going to make all these mistakes that Jay was talking about. I'm going to make the microest service I can. So I'm going to even have my user login endpoint be one service, and my password reset be a different service. Doesn't get more micro than that, right? Well, what is the problem with this? Every time someone logs into that system, they might fail, and you want to maybe keep a count of how many times they failed. If they fail 5 times in 10 minutes, maybe you want to force them to password reset. Well, that means that every time someone logs in and fails, that information has to be synchronized between these two systems. It also means that they might fail really fast, and it might take a couple minutes for that information to get over to the other system. So they might be locked out of their account and then have to wait to reset their password until that system finds out about it. So basically, you're creating this kind of chattiness between these two services. Or even if you're using an event bus, there's a lot of events going into that event bus and a lot of subscribers to those events. Basically, anytime something happens in one, the other one cares about it. Anytime it happens in this one, that one cares about it too. So that's too chatty. I think that's clearly too chatty. So somewhere right in the middle is kind of what you're aiming for the right place to break up your microservices. If you have too much inter-service communication, you're going to have a very slow application with a lot of data latency. And if you have your service size too big, well, then you really don't have microservices. Eventually, if they get big enough, they just become a monolith again, right? So somewhere in the middle is kind of where you want to set that line. The 5th problem that I see is a lot of people starting a greenfield project as microservices. Why is that a problem? Well, greenfield microservices is actually harder than brownfield microservices. If you're not familiar with those terms, greenfield basically means starting from scratch or starting a new project, and brownfield is migrating something existing. The reason why it's harder is 4 things. Number 1, if you have existing code, even if it's a monolith, even if it's a bad monolith, you have all of the relationships already documented on how the different parts of the application works. You could even do maybe an object diagram or a database diagram and see very clear places where you could actually break your microservices apart. If you've ever done a database relationship diagram, you've seen all those relationship arrows between all the database tables. You know that there'll be like a little clump of tables that have lots of interaction with each other, and then there'll be like maybe one line that'll go up to this group over here, right? That one line is kind of your indication that, oh, this might be a good place to break these microservices up. If there's an existing system, there's also someone to talk to, hopefully, if they haven't left the company from having to maintain a ball of mud monolith. There's someone to talk to that knows how the system works. Also, the system already works. Maybe it doesn't work great, but what's the number one thing that stops us from doing a good job with software engineering? Time, right? There's always deadlines. Has anyone ever had a project where their boss said, you can get this done whenever you want? So what's really great about having a system that already works, even if it's not great, maybe it's slow, maybe it's not ideal in some ways, but it works. It buys you time to do microservices carefully so that you don't make some of these mistakes that we're talking about. And then the last one, I think, is a really important one. It's the ability to have a baseline to compare to. You're trying to migrate to microservices theoretically because you're trying to make a better system than the system that you had before. And if you're trying to migrate to microservices, wouldn't it be nice to have a system that you could actually measure against to say, are we making something better or are we actually making something worse? And that's something that you have when you're doing a brownfield migration. There's a bunch of different approaches to brownfield migration. If you've been in any of the other talks about microservices, I know they've mentioned some of these. The Strangler fig pattern is often put forward as the best one, which I would agree with. It actually comes from this really crazy plant that's in, I think, Australia, that starts growing in the tops of trees and it shoots these vines down the trees. When the vines get to the ground, they'll go into the ground and they'll wrap around the tree's roots. And they'll actually choke that tree off so it doesn't get the water or nutrients that it needs from the ground anymore. Eventually that tree dies and it just is like a backbone for the vine so that it can get access to the sun, which is up high. So it's kind of a violent, slow motion violent example, but it's actually a really good analogy for how you can do a migration gradually from a legacy application to a modern application. If you create a facade layer, you could imagine this being like an API gateway or something. You can start with a very small modern application and a very large legacy application. Maybe it's 100% legacy and 0% modern. And you can gradually move endpoints from one to the other, rewrite them in the modern application. All that time you're updating your facade, maybe your API gateway, so that the client applications are never aware of any of these changes. It all looks exactly the same to them, and everything continues to work the way it did before. But eventually, you finish migrating, and this buys you the time to basically put your application out with updates to it right away without having to finish the whole thing and wait 3 years while you're migrating it to microservices. Problem number 6 is creating coupling through cross-cutting concerns. Some of the common cross-cutting concerns that microservices have are all of the security or authorization and authentication related things. Logging is a common one. If you're going to debug a microservices application where a user interacts with this microservice, which updates its database and publishes an event to a bus, and then 3 things subscribe to that event and they update something in their database, you can imagine if something goes wrong, it's going to be really hard to figure out. If you don't have really good logging, it's going to be hard to figure out what happened. So logging is very important, but it's also very difficult to do it in a way that doesn't create coupling between those microservices. And then the last one is configuration. So my general advice with this is to not reinvent the wheel. I've given this talk maybe 20 times in the last 2 years, and almost every time someone has come up to me afterwards and said, we're doing microservices and we created our own event bus. My first response to that is, that's really cool. You probably should not create your own event bus. No offense, I'm sure you're a great engineer, but these problems have been solved. They seem really interesting and cool to solve. It's the type of thing that would get an engineer very excited to say, ooh, I know how to do that. I know how to do publish and subscribe, and I'll write events into a database, and I can do this to make sure that guaranteed delivery works. I guarantee you will not do as good a job as Kafka or Azure Event Bus or any of the other services that exist out there that already do this. Same thing for logging. There's a logging library called Seq, S-E-Q, that is built for doing distributed logging. It's built to be loosely coupled, fault tolerant. It can queue up events even if the storage, the place it's storing the logs goes offline. It can store them for a while and then write them when the log becomes available again. And most importantly, it's technology agnostic, which means you're not tying in all of your teams to some particular technology stack by saying, oh, we created our own logger class in C#. Now everybody has to write their microservice in C#, right? Or we created it in whatever language, but put it in NuGet. Now you have to do it in .NET. You can't write it in some other language. So don't reinvent the wheel when it comes to these cross-cutting concerns. There similarly are things out there for authentication and authorization. I'm sure you've heard of OAuth and those types of things. And logging, I recommend Seek. And there's other services out there for configuration as well. Number 7 is the use of synchronous communication. This is maybe the worst one. So I told you that story at the beginning of a client that was coming to us with a microservices application that was performing poorly. Their biggest problem was this problem. They also had a bunch of the other ones we talked about, but this was the main reason why their system performed so poorly. So just give you an example here. Imagine you have a orders service and a customer service. These are in separate microservices from each other. Your orders endpoint wants to take an order. It might get a customer ID, and it needs to look up that customer's billing address and mailing address and whatever other information you need for the order. So it's really tempting to do something like this, where you start out the order, you say, oh, I need to look up that customer. I'm going to do a HTTP call or a call to this database to get that customer data. While you're obviously waiting for that customer data, the orders service is blocked. And then that customer data comes back. In an ideal situation, that customer ID is found and that customer comes back and you can process the order. Now, if you're only having one concurrent user, this works great. And so usually when you're developing and you're testing this on your development environment, no problem. Imagine what happens when this service either goes down for maintenance or has some sort of an issue or slows down significantly because of load. Now your order service is blocked, maybe forever if the customer service is down. Maybe it's just blocked for a lot longer time because the customer's service has gotten busy. This is actually what happened in that application I was telling you about. And it basically leads to this situation where if you have arrows between all of your services, where every service is relying on several other services, and one goes down on purpose or on accident, then all the ones that rely on that are now either slow or down, and then all the ones that rely on that become slow or go down, and pretty soon you have nothing working anymore. This is exactly what happened in that application I was telling you about. One single service would get slow, and it didn't matter which one it was. It could be any one. Whatever one you started hitting the most, we started doing some load testing on that application. We would just hit any one service. We would randomly hit one with some load, and all of the other ones would slow down within about 30 seconds. And it was because of this situation. Everybody was waiting for everybody else, and so this is obviously not really a microservice because these are not independent from each other at all. So there's obviously lots of great alternatives to synchronous communication. Asynchronous service bus or queues are an important way to do that. It's probably the best way to do it. Another one is through polling. It's an option that you can use. There's also a pattern called the circuit breaker pattern. I would recommend this as maybe like the worst case scenario. If you absolutely have to call from one service to another service synchronously, you can at least use a circuit breaker pattern. The idea of the circuit breaker pattern is you write some code that wraps around that call, and it keeps track of failures. So if there are 5 failures in a minute calling service X, then that wrapper class will actually shut down and say all calls to service X are going to be disabled from now. I'm just going to return an error every time, which then at least speeds up your application. It starts getting errors back right away instead of having to wait for service X to respond. Problem number 8 is a really nefarious one, and that is actually coupling your microservices to each other through the events that they've published. This might even not seem possible to you at first blush, but I've seen this happen. So basically the idea is that your services should actually publish events that say, hey, this just happened in this service. If anybody else who cares about that can do something about it, here's some data related to that event. Well, what happens later when the service that's publishing that event decides they need to make a change to that event, right? well, now there's a potential to break all those services that were subscribed to it. So there's some very basic rules that you'll find published a lot of different places that talk about what to do to make sure your events don't break. One of them, the first one, is rule number 1, no new required fields. So don't create a new field that's required on an event. All optional fields if they're new. So once an event has been published the first time, from then on, any fields after that have to be optional with a documented default. Second rule is anybody subscribing to something that sees an unrecognized field should just ignore it, but keep processing, right? So like, well, that's a new field. I don't know what that means because when I was written, that didn't exist, so I don't know what to do with it. I'm just going to ignore it. But if I'm going to publish an event about what I just did, I'm going to take that data and I'm going to forward it on in my event so that everyone else who might know what that means knows what to do about it. Rule number 3, consumers of optional fields use the default values when they're missing, right? So if you get a data field on an event that you weren't written to know what it means, you're going to pass it on, but you're also going to use the default values, which should be published in the event. And then the last one is if you cannot satisfy all 3 of those rules, you need to do a new event that maybe has a new required field. The solution to that is to create a new type of event, which means that you might have to publish 2 events now. Going back to my hotel example, every time a new room is added, maybe you've got room created 1 and room created 2, right? Because now there's one that has some new required fields that some services know about and some don't. I often get a question about how do you handle, like this creates a big mess, it seems like, how do you handle this? If you do true microservices and you have actual separate teams working on them, my recommendation is to have sort of like a event council that has a representative or a project lead or chief architect or whatever from each of those teams that meets on a regular basis and talks about these events. Maybe a day comes where you publish a new event and you can tell everybody about it. Maybe they want to put that in their backlog to handle that event with some of that new data in there. Or maybe the day comes when an old event that you were publishing isn't subscribed to by anyone anymore because it's been replaced and you can actually turn that off. That's something that you would find out in an event council where you go maybe once a month and everybody talks about what events are being published in there. Problem number 9 is not automating the build and release cycle. You wouldn't believe how many companies, maybe you would, still don't have automated CI/CD pipelines. But when we have a client come to us and say, hey, we're considering microservices, this is one of the first questions we'll ask them. The very first one is why do you want to do microservices? And making sure they have a very good reason. The second question is, do you have automated build and releases? Because if you don't, you're kind of avoiding the whole benefit of microservices, which is the ability to update these things frequently and independently. And if you're doing it manually, that's very time consuming and it's very prone to error, human error, especially with things like configuration or releasing to the wrong environment at the wrong time. You want to have all of this stuff automated first before you even think about implementing microservices. The last one, which I've alluded to several times throughout the talk, is mismatched teams. I mentioned that Google defines microservices architecture as both an architecture and a team organization. And you might be familiar with something called Conway's Law. Conway's Law, to paraphrase it, basically says that a team that builds a system will build a system that looks an awful lot like that team. The common example that's always given, it's a bit of an old-fashioned example, but it's if you give 4 teams the job of writing a compiler, they'll write a 4-pass compiler. Nobody's going to volunteer and say, well, the work our team did isn't really necessary because it mostly overlaps with the work the other teams did, so go ahead and just throw away what we wrote and just use yours. If you have 4 teams, you're probably going to get 4 stages to your compilation process. The same applies to modern applications. If you're building microservices, but you're building it with 1 team, I can almost guarantee that somebody is going to fall for the temptation to put data in a shared database, or connect directly through a synchronous HTTP call, or connect directly to another database, or something like that, because everybody knows the whole application, everybody works on the whole application. This is really just not a good fit for microservices. If you have one team of 5 or 6 people, and that's it for your whole organization, it probably doesn't make a lot of sense to do microservices unless each person is doing their own, totally independently of each other. And that doesn't make a lot of sense. So I would say, if that's what your team looks like, probably microservices automatically are not the right fit for you. You want your team to look more like this if you're doing microservices. You want to have a team for each microservice. Now, I'm not a purist. It doesn't have to be 100% like this. You might have 2 microservices that are a little smaller, and they can be kind of grouped together and assigned to a single team. But the idea is that every team has their microservice or microservices that they're in charge of, and there's really not a lot of cross-contamination between those. All right, so that brings us to the end of my list of 10 things. So hopefully what you're going to walk away from this with is that monoliths can be good too. You can actually scale those if you need to. Microservices are great for the right type of applications, but if you don't have a really good reason to use them, they're very dangerous, and there's a very good chance you'll build a distributed monolith. Even if you think microservices could be a good fit, if this is a brand new application, consider building it as a monolith first and then migrating it at some point in the future. There's a lot of advantages to using that process. If you have a single team that's small, probably a monolith is the best fit for you. If you have a large team where it would make sense for it to be split up into little groups, then maybe microservices is a good fit for that team. And then finally, when you are implementing microservices, hopefully you remember some of these 10 common mistakes that I showed you to make sure that you don't fall into those same traps. So that brings us to the end of my content, and we've still got a few minutes left. So I know there's some microphones in the back, and I'd be happy to take any questions that anyone is willing to say out loud in front of everyone. Any questions I can answer? You can just raise your hand, or, yep, there's the microphone is ready. Any questions? I answered everyone's questions so perfectly in my talk that you don't have any questions. All right, well, if you think of something and you want to chat afterwards, I'll be up here for a little bit before I have to hop on a train to Lisbon. But you can also reach out to me at any of these places, or feel free to use this to join me for my office hours. I'd be happy to chat with you at some time that's convenient for both of our time zones. Thanks so much for coming to the talk today. I hope it was useful for you.